Hello class, this is going to be a flipped classroom on limiting reactant. I highly recommend that during this video you pause and take notes because this is probably going to be one of the more complicated types of calculations that we will be discussing. So what exactly is limiting reactant? Limiting reactant is when you're doing an equation and one of your reactants will run out before the other one will. Which means you don't necessarily have the exact amount of both you need. You have excess of one, and the other you will have only so much that you will use up. So let me start before we get into any chemistry. Let's do a problem that has no relation to chemistry. Let's just talk about lunch. So let's say for lunch I wanted a grilled cheese sandwich. Nothing fancy, just a normal, basic, quick and simple grilled cheese sandwich, which will require 2 pieces of bread and 1 piece of cheese. Now I know I could cut the bread in half, or I could put extra cheese on it or tomato. I just want to make it simple. 2 pieces of bread, 1 piece of cheese, and that will make 1 sandwich. However, I happen to be really hungry today, so I'm going to make 2 sandwiches, which means I'm going to need double the amount of bread, 4 pieces of bread, and 2 pieces of cheese. As you can see, the 4:2 ratio is the same as the 2:1 ratio. All these numbers here are in the same proportion as all these numbers here. But what happens when I go to make my grilled cheese sandwiches and I notice that I have 4 pieces of bread, but I only have 1 piece of cheese? How many sandwiches can I make? Well, the answer is I can only make 1 sandwich. Now, why can I only make 1 sandwich? Oh, because I only have 1 piece of cheese. But you might argue, you have 4 pieces of bread. Can't you make 2 sandwiches? After all, the ratio between the bread and the sandwiches is 4:2, right? I would if I had enough cheese, but my cheese is my limiting reactant, which means I am going to run out of cheese, and then when I am done, I will have excess bread. I will use up 2 pieces of bread, but then I'm going to have 2 pieces left over, and until I get another piece of cheese, that bread's just going to sit there, probably go moldy, and I'll have to throw it out. So what does this have to do with chemistry? Well, these numbers here could be looked at as coefficients. This is just like a chemical reaction. So let's take a look at, once again, my classic reaction that I've done over and over again. 4NH3 plus 3O2 makes 2N2 and 6H2O, which means for every 4 moles of ammonia and 3 moles of oxygen, I'll make 2 moles of nitrogen and 6 moles of water. But what happens if I don't have exactly what I need? Let me give you a situation where I have this. I have 5 moles of NH3 and I have 5 moles of oxygen, and my question is, how many moles of water will I make? And to keep it simple, I'm only going to do a mole to mole problem. We won't do any mass to mole or mass to mass. We'll keep it simple. So once again, I have 5 moles of ammonia and I have 5 moles of oxygen, and I need to figure out how many moles of water I'm going to make. The problem is, which number do I use? Do I use this one or do I use this one? You might say, well, doesn't it not make a difference? They're both 5. Well, it does make a difference because a 4:5 ratio is not the same as a 3:5 ratio. So do I do 4/5 equals 6 over x? Or do I do 3/5 equals 6 over x? Which one is correct? To answer that question, I need to know which one of these is my limiting reactant. Which one will I use up? Because I don't want to use the excess one, because the excess one is not accurate. It will not get me the correct answer. So here is how I figure out limiting reactant. And before I start, let me state there is more than one way to do this. This is just the way that I'm going to show you, and hopefully it'll make sense and work for you every time. So what I do is I do the following. I first set up the ratio, not between the water, but between the 2 reactants that I have, my ammonia and my oxygen in this case. And that ratio is 4:3. Then I simply pick one of the reactants and I say, I don't know, maybe ammonia is going to be my limiting reactant. And it's completely all right to guess. Just pick one and then see what happens. So I'm going to guess that ammonia is my limiting reactant. So I'm going to make a proportion 4 is to 3 as 5 is to X. In other words, for every 4 moles of ammonia, I know I make 3 moles of oxygen. My question is, if I have actually 5 moles of ammonia, how many moles of oxygen would I need to make this work? So I set up a proportion, I cross multiply, I'll save you the trouble of showing you the calculation. I did it on the calculator, and I got the answer to be 3.75 moles of oxygen. And notice I wrote the word needed. That's what I need if I intend to use up all my moles of ammonia. So now let's just look practically at what I have compared to what I need. I have 5 moles of oxygen. That was given, I know that. But I only need 3.75 moles of oxygen. What does that mean when you have more than what you need? Well, I believe we would call that excess, right? I have more oxygen than I need, which means my ammonia is actually going to be used up first. It is my limiting reactant. So I guessed right. So, therefore, ammonia is indeed the limiting reactant, and oxygen is in excess. Take a moment, look at this, make sure you get that. This was my ratio that I knew for a fact, those are my coefficients. I picked this one as my guess. I solved for this for the one I needed, and I found out that I needed less than I actually had, which means what I had was in excess. Now, what if I chose wrong? Well, here's the beauty of this system. It doesn't matter which one you choose, it still works. So one more time, let's do this problem again, but this time let's do it by me picking the wrong answer. As you can see, I have my ratio again, my equations all set up, and I was given this information and this information. However, this time, I'm going to set up the ratio 4 to 3 as X is to 5. Or in other words, I'm going to guess that oxygen is my limiting reactant, and I want to see how much ammonia I would need if this actually is limiting. So I cross multiply and I solve for X, and when I solve for X, I get X to be 6.67 or 6 2/3 moles of ammonia needed. I need over 6 moles of ammonia to make this reaction work. The problem with that is I only have 5 moles of ammonia. I need 6.67, I have 5. I don't have enough, which means this is limiting. I do not have enough to make it work to use all 5 moles of ammonia, which means, 5 moles of oxygen, which means the oxygen is excess, just like before. So even when I guess wrong, I still know the right answer. I still know that we don't have enough NH3, so NH3 is still limiting, and oxygen is still excess. I hope this was helpful. Now, the only thing I haven't done here is I haven't done a problem starting with grams instead of moles, which could actually happen. The only difference in that type of problem is you have to, and I mean you have to, there is no other choice, you have to turn both grams into moles before you can go on any further. So if you're given grams of your reactants, you must change them both to moles and then do everything I just did here. So the only extra step in doing a limiting reactant problem when they're both grams instead of moles is change them to moles. After that, you just pick one as a guess, figure out if your guess is right, and then you're done. So let's now finish the problem. Now that I know that ammonia is limiting, I no longer even have to look at the oxygen. I can just do my ratio. 4 over 5 equals 6 over X. I'll write that down here. 4 moles of ammonia over 5 moles of ammonia, which is what I really have, and remember that's limiting, is equal to 6 moles of water over X, and I'll cross multiply, and I will do 5 times 6, which is 30, divided by 4, and I get that I will need, or I will make, 7.5 moles of water. And just to conclude this video, what happened if I had guessed the wrong one? Well, if I had guessed the wrong one, let's see what would have happened. I would have done 3 moles of oxygen is to 5 moles of oxygen equals 6 moles of water as to X. And if I cross multiplied and solved, 6 times 5 is 30, divided by 3 is 10. I would have gotten the answer to be 10 moles of water. So I would have assumed I would have made 10 moles of water. But that's just not going to happen. I'm not going to make 10 moles of water because I'm not going to use up all 5 moles of oxygen. I already figured out that oxygen was excess. That's why I had to use this ratio and not this one. And that is our lesson on limiting reactant.